For 200 years, they dreamed of building a bridge.
The first plan was in 1802. Horses and oil lamps.
In 1880, they actually started digging a test tunnel.
But the sea always wins. After 4 failed starts, the British and French governments finally agreed. 2 nations. 1 incredible risk.
They weren't just building a tunnel, they were fusing 2 economies.
2 rail tunnels and 1 central service tunnel. On the French side, the village of Sangatte became ground zero.
In England, they dug from the legendary cliffs of Dover.
The biggest problem? Geology.
They had to tunnel through this, the chalk marl. Hard, but mostly watertight.
If they drifted a few meters high, they hit porous rock and guaranteed flooding.
Drift too low, and the clay would seize the machine. They were aiming for a layer only 20 meters thick, 75 meters under the sea. Years of seafloor testing narrowed down the route.
The UK problem. How do you build a massive portal into a vertical cliff face?
They dynamited 250,000 cubic meters of rock just to create a flat base. A new piece of Britain was made from chalk and dynamite.
The French built a vast 60-meter deep, circular pit near the coast.
This allowed their tunnel boring machines to launch underground.
The French pits were deep. The pressure was already immense.
The tunnel machines were not bought. They were manufactured. 11 tunnel boring machines, each one a self-contained subterranean factory. The cutter head alone weighed 600 tons.
This thing has to grind through 20 miles of solid rock.
Cut, clean, line. A simultaneous, continuous process. Hydraulic arms would lift and seal the prefabricated tunnel segments.
These segments are watertight, the only thing standing between the workers and the ocean.
The UK launched 6 machines, 3 for the land, 3 for the sea.
The French machines were different. They were sealed face excavators. The temperature inside these unventilated tunnels could hit 50 degrees Celsius.
The French side had wetter, looser rock,
It wasn't just
so they
drilling
used
rock.
pressure to hold them
It was a
up.
pressure cooker, miles from the sun. The service tunnel took the lead. Every meter was a gamble. They were looking for water seepage, the earliest warning of trouble.
Every leak had to be found and grouted immediately. Massive floods threatened to trap entire TBM crews.
The pressure was crushing. Not just the sea, but the schedule.
To stay in the chalk marl, they needed absolute precision.
A beam of light kept them on the 20-meter path.
The primary guide was a gyroscope, an electronic compass that knew every turn.
The operator steered the 1,000-ton machine like a car. The logistics of removing 7.5 million cubic meters of spoil was monstrous.
The British spoil was dumped into the sea, forming a new 90-acre coastal platform.
They literally pushed the English Channel back.
When you don't know where to put the dirt, you build an island.
The main rail tunnels followed, larger and faster.
The rail tunnels had to be perfect to handle high-speed trains.
The track was specially designed to...
Two separate worlds, drilling blindly toward a common point.
They relied on the gyroscope. Any error, and they would miss completely. Final moment of truth. The first pilot hole. Breakthrough. December 1, 1990. The handshake heard round the world. The final alignment error, less than half a meter.
39 kilometers apart, 75 meters down. That is impossible precision. The chalk marl held. The risk paid off.
The main rail tunnels followed, meeting over the next few months.
But what happened to the tunnel boring machines?
The UK TBM was too big to turn around. They sealed it up.
6 huge British machines were buried beneath the English Channel.
1,000-ton engineering tomb.
They sacrificed the machine to save the time.
The French TBMs were dismantled and brought back to the surface.
The tunnels needed air, light, and safety.
Giant fans push fresh air through the length of the tunnels.
A failure in ventilation means a catastrophe. The system cycles the air every few seconds.
Power and signal cables for the 25 kV electric trains. The track was precision welded for high-speed operation.
Trains travel at up to 160 kilometers per hour underwater.
Touching that 25,000-volt line is a permanent mistake.
one problem. The train pushes a wall of air ahead of it.
Fire was the greatest fear.
Every 375 meters, an escape route. The service tunnel is the lifeline. A complete fire suppression system lines the entire tunnel. Emergency lighting is redundant and powerful. The first train runs, but the project is in chaos. The cost had ballooned from £4.7 billion to £9.55 billion.
The engineering was a miracle. The finances?